Hello everyone, my name is Dariusz Kulus, and today I would like to tell you a few words about cryopreservation of ornamental plants. Ornamental plants, due to their unique beauty and the great variety of shapes and colors, have been an important element of human culture and economy since ancient times. Every year, hundreds of new cultivars replacing the current assortment are produced. However, due to the change in consumer preferences, the cultivars which are out of fashion today may once again be attractive for potential buyers. Moreover, they are a great breeding material source, and therefore the protection and storage of valuable genetic resources are gaining importance. Today, cryopreservation, which means storage of plant material at ultra-low temperature of liquid nitrogen, minus 196 degrees, is believed to be most promising storage method. Over time, several cryopreservation techniques have been developed. Most of them require the use of chemical compounds known as cryoprotectants, such as dimethyl sulfoxide, glycerol, ethylene glycol, or different carbohydrates. Cryoprotectors interact and alter water distribution inside and outside cells and dehydrate them. These substances are protecting the cells from injury throughout freezing. The traditional methods, also referred to as two-step freezing, were the first ones developed. They are based on controlled slow freezing of the material to a certain terminal temperature stimulating freeze dehydration, and later on rapid freezing or direct immersion in liquid nitrogen. Despite high efficiency, two-step freezing represents several disadvantages. First, it can only be used with undifferentiated materials such as kali or shoot tips of cold-tolerant species. Therefore, it cannot be used with tropical ones, which are popular ornamental plants. Secondly, it is expensive, for it requires special freezing apparatus. Therefore, today, cryopreservation is based on the so-called modern vitrification-based methods. With some orthodox seeds in Poland, direct immersion in liquid nitrogen or simple physical desiccation are possible, while with other species, a 1 till 14 days preculture on a sucrose-enriched medium with an optional addition of abscisic acid or proline is efficient. For most plants, however, a typical vitrification-based protocol is a much more complex process. During a typical vitrification procedure, the explants are incubated in a diluted mixture of cryoprotectants, after which they are transferred to a highly concentrated plant vitrification solution and placed in vials and immersed in liquid nitrogen. The vitrification method is provided with several modifications. One of them is the droplet vitrification technique. In this procedure, explants, incubated previously in loading solution, are placed in a drop of plant vitrification solution on aluminum foil strips prior to direct immersion in liquid nitrogen. The technique is based on the high thermal conductivity of aluminum, which increases the freezing and thawing pace, allowing for better survival of the material. Since some cryoprotectants may be toxic for plant tissues, the most popular cryopreservation techniques are based on explants encapsulation in sodium alginate. Afterwards, the physically protected explants are either chemically pretreated with cryoprotectants or osmotically dehydrated with sucrose solutions. Next, the explants are additionally physically desiccated. A properly protected tissue can be stored in liquid nitrogen for an indefinite time. For thawing, cryovials are placed for 3 minutes in a water bath at 38 degrees. Next, the explants are transferred on the recovery media to stimulate the regrowth of the plants. In theory, cryopreservation does not influence the stability of the stored tissues. Still, one should keep in mind that stability markers, phenotypical, biochemical, or molecular, should be applied every time before introducing new cryopreservation procedures or after freezing new materials. The current achievements offer the possibility of applying cryopreservation for the purpose of long-term storage, breeding, and the protection of ornamental species with maintaining their stability. Therefore, cryopreservation may be considered as the future method of plant genetic resources conservation. Thank you for your attention.